This is May 2024, R version P1. Let's start with the first question. It's find and integration of this expression, writing your answer in simplest form. Let's start with rewriting the expression in a form that can be integrated. So it's half x to the power of 3 plus 3x to the power of negative half minus 4 with respect to x. Now, let's integrate by adding 1 to the power and divide by the new power. So it's going to be like this. Power 4 divided by 4 plus 3x to the power of half divided by half minus 4x and of course plus constant. So half divided by 4 will be 2x power 4. Then 3 divided by half will be 6x to the power of half minus 4x plus c. Piece of cake, 4 marks gained. And now you must show all the stages of your working. Solutions relying on calculator technology are not acceptable, which means you have to show all the stages of your working. Let's take the first one, taking the first inequality and doing the solution. Let's see, then expand first. This is A, expand will be 5x plus 15 greater than 8x minus 20. So we're going to have 8x minus 5x smaller than 15 plus 20. So we have 3x smaller than 35. So we can say that x is smaller than 35 over 3. 35 over 3 in decimal means 11.667. So this is the decimal size of x, which is less than. Going to be, we have a quadratic equation, x squared minus 6x plus 1 greater than or equal 0. When you start trying to factorize it, it won't be factorized. So you have to use the complete square form. So it will be x minus 3 all squared minus 9 plus 1 equals 0. Then we're going to have x minus 3 all squared minus 8 equals 0. It will be x minus 3 equals positive or negative root 8. So finally, we're going to have x equals 3 positive or negative 2 root 2. As an inequality which is greater than 0, so x is greater than 3 plus 2 root 2. So we are going to have greater than or equal, as we have here, greater than or equal. And x is smaller than or equal 3 minus 2 root 2. Going to the final part, hence find the value of x for that satisfy both inequalities. So satisfying both inequalities, you have to put them on the number line and make your steps clear. We have the first one, 35 over 3, and it's open circle, and x is less than, going down. Also, we have x greater than 3 plus 2 root 2, which is almost 5 point something. So it's smaller than this, so it is going to be a closed circle. This is 3 plus 2 root 2, and going up. Also, we have x smaller than 3 minus 2 root 2, which is a closed circle as well, and going down. Using these two inequalities, we can shade the region where the lines are crossing or meeting together. So we have two separate answers. X is smaller than 35 over 3 and greater than or equal 3 plus 2 root 2. In this part, it is only 3 minus 2 root 2 and x x is the smaller than or equal this value. So we have two separate answers. Answer number one, which the value with x between the two values we have. So we have to draw the number lines so we can see the crossing lines and see where the two inequalities intersect. That's it. Number three, they keep repeating this title, so you are able to read it every time and remind you with the fact that you have to show your work. First, rearrange y. It will be x power 3 plus 96 x to the power of half plus 5. So dy over dx, or y dash, first derivative will be 3x squared plus 48x to the power of negative half. And the constant is 0. Piece of cake. Going to number 2, d2y over dx squared equals 0, which is the second derivative. First, find the second derivative. Differentiate the first derivative again. It will be 6x minus 48 times negative half will be negative 24x to the power of negative 3 over 2. When you solve an equation like this, it will be 6x minus 24 divided by x to the power of positive 3 over 2 equals 0. So multiply all terms by x to the power of 3 over 2. It will be 6x to the power of 5 over 2 minus 24 equals 0. So it will be x to the power of 5 over 2 equals 24 divided by 6. So x is equal to 4 to the power of 2 over 5. You can leave it like this, or you can say it is like 8 to the power of 1 over 5 over the fifth root of whatever. I believe this is going to be much easier. You can simplify it if he wants to. Let's see if he wants a separate case. Yes, we have 2 to the power of k. Now we have to factorize the 4 into 2 to the power of 2, all to the power of 2 over 5, then multiply the powers. It will be 2 to the power of 4 over 5. So clearly you have to read all the question until the end. Otherwise, you would have lost the final mark. Moving to number 4, we have the curve C has equation y equals 2 over x plus 3x minus 4. The straight line L has the equation y equals kx plus 2. Where k is a constant, show that L meets C when the equation takes place. Let's do it. So we have kx plus 2 equals 2 over x plus 3x minus 4. So in this case, multiply by x. So it will be kx squared plus 2x equals 2 plus 3x squared minus 4x. Put them on the right side or the left side. It's up to you. Kx squared minus 3x squared plus 2x plus 4x minus 2 equals 0. So take the x squared as a common factor. So we have k minus 3 plus 2x and 4x will be 6x minus 2 equals 0. So this is part A of the question. Part B says, hence find the value of k for which L is a tangent. L is a tangent, that means the two curve and the line intersect at one single point. That means the solution of this equation should be only one root. So we are going to use the discriminant, which is b squared minus 4ac is equal to 0. So we have 6 squared, which is 36, minus 4 times k minus 3 times c, which is negative 2, is equal to 0. So we have 36. Negative 2 and negative 4 is positive 8 times k minus 3 equals 0. Expand and simplify. So we have 36 plus 8k minus 24 equals 0. So we have 8k plus 8 is equal to 0. So 8k, 36 minus 24 is positive 12. So 8k speaking of which, so we have 8k plus 12 equals 0. So k is equal to negative 12 over 8. In simplest form, divide both of them by 4. It will be negative 3 over 2. Moving on to number 5. First one, fully factorized. So taking x as a common factor will be our have 9x squared minus 10x plus 1. Then we have x, then factorize both sides will be 9x times x, 1 times 1, and both are negative. Also, you have to show all your working. You can't put it on a calculator and get it done. You can't. Okay? B, for part B, he says, hence solve. By looking at both equations here, we can say that it is the same equation, replacing every x with 3 to the power of y. So we can solve this equation, x times 9x minus 1 times x minus 1 equals 0. So we have three solutions, x is equal to 0, x is equal to 1 over 9, and x is equal to 1. In both cases, replace every value of x to 3 to the power of y. So we have 3 to the power of y equals 0, which is nonsense, because every exponential function must be greater than 0. So this is the rejected answer. X, which is 3 to the power of y, equals 1 over 9, which is 3 to the power of 2. So 3 to the power of y is equal to 3 to the power of negative 2. So y is equal to negative 2. Piece of cake. Also here, x is equal to 1. So we have 3 to the power of y is equal to 1. That means y is equal to 0. So these are the three solutions for this equation, and working all the factorization, showing all your working. Going to number 6. In this question, as you can see, it's radians. Let's read the given carefully, put everything on the figure. Then we can decide what to do. First of all, change your calculator into radians. When we read this, figure 1 shows an entrance of a tunnel. So we have the shape of the entrance, consists of sector and two triangles. AFE is a straight line, which means that the angle here is 180, or in other words, pi. We have FE equals EF, AF equals FE, equals 6.4. So we have here, both of them are 6.4. We have FD and FB are equal, so it's 6.2, which means also that DE is equal to AB. In all cases, we have the angle BFD is 2.275 rad. Show that angle AFB, which is this angle, equals 0.433 in radians. So we're going to do what? We are going to say that the straight angle we have here, the straight angle, this angle, that the angle which we have, both of them are equal. So angle AFB is equal to pi minus 2.275 divided by 2. So both angles here are equal, so the answer is 0.433. Now, moving to the other question, the second question, B, we have find the perimeter of the entrance. Perimeter of the entrance means the sum of all sides. This one, plus this one, plus this one, plus the arc. These two sides are equal. And this one is 12.8. Very clear. So we need to find the length of AB or the length of DE or any of them and then multiply it by 2 plus the length of the arc. Let's find the length of AB using the cosine rule. It will be square root of 6.2 squared plus 6.4 squared minus 2 times 6.2 times 6.4 cosine the angle 0.433. Go to your calculator, change everything into radians, and find the length of this side, which is going to be 2.71. Perfect. Alright? Okay, that's fine. Then go to the length of arc. Length of arc will be r theta rad. R is 6.2 squared times theta rad. I'm sorry, r theta rad. I'm so sorry. 6.2 times theta rad, which is 2.275, which will be 14.105. Then get the perimeter. Start with the 12.8, the length of the longest side here, this one. Then the two sides to multiply the 2.7 by 2, it will be 2.71 times 2 plus the length of the arc, which is 14.105. The final answer will be to one decimal place of the three significant figure, 32.3 meters. Then go to the last question. Find the cross-sectional area of the entrance of the tunnel. So we need to find the total area. First, we are going to say that the total area is the area of the two triangles. We have two triangles plus area of sector. Area of two triangles, which is 2 times half AB sine C, which is 6.2 times 6.4 sine the angle between them. The angle between them, which is 0.433, plus the area of sector, which is half r squared, 6.2 squared times theta rad, which is 2.275. The 2 here is cancelled before doing your calculations. Then do your further calculation. The final answer will be 2 times 8.325 plus 43.725. So the final answer will be 60.4 square meter. It's very clear that we can do the area of one triangle and then multiply it by 2 or cancel the 2 at the beginning. It's totally up to you. Then add the area of sector, which is half 6.2 squared times 2.275. So guys, you can do them separately or you can do them as one single step. You are going to gain the same mark. Moving to the next question. Number 7, we have the straight line L1 shown in figure 2 has equation 5y equals to x plus 10. The points A and B lie on L1. The point A lies on the y-axis. Stop at this one. Lies on the y-axis. That means x is equal to 0. So y is going to be 10 over 5, which is 2. So we have point A, 0 and 2. Point B has x coordinate 10. So when x is equal to 10, y is equal to 30 over 5, which is going to be 6. So point B is 10 and 6. Piece of cake so far. Find the distance AB, writing your answer fully simplified. The distance between A and B, let's post here. So AB is equal to square root of x2 minus x1 squared plus y2 minus y1 squared sorry, so it's square root of x2 minus x1, which is 5 minus 0. It was 10, I'm sorry, 10 minus 0. And 15 minus 2, all squared. So we have a square root of 100. 13 squared, 169. So it will be 2 root 29. Okay, here's exercise. So the distance AB is x2 minus x1 squared and y2 minus y1 squared. It's 10 minus 0 all squared plus 6 minus 2 all squared will be square root of 100 plus 16. In simplest form, it will be 2 root 29. That's the normal thing. The straight line L2 also shown in figure 2, the straight line L2, here it is, this one, passes through points B and C. Passes through B, so we know B. B is 10 and 6. And perpendicular to L1. That's great. Perpendicular to L1, finding the gradient M1 for the line L1, which will be 2 over 5. So the gradient of L2, which is M2, will be negative 5 over 2. Looking at the equations, so finding the equation, find the gradient from the equation of L1 and then get the negative of the reciprocal. Find the equation of L2. The equation of L2, we are going to use the point B and the gradient negative 5 over 2. The point B is 10 and 6. Use y1 minus y2, so it's y minus 6 equals negative 5 over 2x minus 10. Simplifying your answer, y is equal to negative 5 over 2x plus 25. Yes, 5 over 2, 25 plus 6. So y is equal to negative 5 over 2x plus 31. Multiply the whole thing by 2. It will be 2y equals negative 5x plus 62. Put it in the form that he requires. A, B, and C, where A, B, and C are integers, will be 5x plus 2y minus 62 equals 0. That's wonderful so far. Right. The line L2 crosses the x-axis. Stop here. Crosses the x-axis at the point C. Crosses the x-axis. That means you have to put y equals 0. طيب حلو قوي. Y equals 0. That's perfect. So we have 5x minus 62 equals 0. So x is equal to 62 over 5. You can leave it like this as an exact value and use it. So we have point C, 62 over 5 and 0. Type. What does he want? Point D is such that
said to big fat family linked.
The point D is such that A, B, and C, A, B, C, and D are the vertices of a rectangle. Find the area of the rectangle. Perfect. We have, going back to, we found that the length of AB is 2 root 29. Earlier in this question, in part A, can we find the length of BC? Yes, we can. Yes, go get the length of BC. So BC is equal to square root x2 minus x1. B is 10 and 6. C is 0 and 62 over 20, 62 over 5 and 0. So we have 10 minus 62 over 5 all squared plus 6 minus 0 all squared, which is under the root, and finalizing things like that will be 6 root 29 over 5. So the area will be what? Area of rectangle, which is base times height, which is 6 root 29 over 5 times 2 root 29. Does he want the exact value? He didn't say, he didn't mention, so you can put it in a calculator, and it will be 69.6. So piece of cake, because you have done part of the question before. So to find the area of the rectangle is base times height. Find the perpendicular side and do it. Number 8. A curve C with the equation y equals fx passes through the point R 4 and 13, given that f dash of x is equal to 2 times x minus 3 times 3x plus 2. Use integration to find f of x, giving your answer in simplest form. Perfect. Let's first do what? Rewrite this equation and expand the brackets. So a f dash of x will be 2, expand the bracket, will be 3x squared plus 2x minus 9x minus 6. Then it will be 2 times 3x squared minus 7x minus 6 multiplied by 2. It will be what? It will become 6x squared minus 14x minus 12. I believe this is the first part. The second part is to integrate to find the equation f of x. Integrate what? So f of x is equal to, integrate this expression, add 1 to the power and divide by the new power. It will be 6x power 3 over 3 minus 14x to the power of 2 over 2 minus 12x plus c. Simplify. So we're going to have f of x equals 2x to the power of 3 minus 7x to the power of 2 minus 12x plus c. Use the point R, which is 4 and 13, 4 and 13, to find the value of c. So we have y is 13, 2 times 4 to the power of 3 minus 7, 4 to the power of 2 minus 12 times 4 plus c. Calculating everything here, so we can find the value of c, which is going to be 45. Write it as in the final form. So f of x is equal to 2x power 3 minus 7x squared minus 12x plus 45. And this is the final form of f of x. Now, let's go to part B. Given that f of x can be written in this form, find the value of the constant p, okay, and the value of the constant q. Also again, let's do the following. What are we going to do? Take the expression he gave us in part B and then expand it. Let's take the expression and do some kind of expansion. It will be like this. Expanding this bracket will be x squared minus 6x plus 9 times px plus q. What are we going to do with it? Just expand it with me and let's see what's going to happen afterwards. Px times x power 2 will be px to the power of 3. Px times negative 6 will be 6px. Px times 9 will be 9 px, and this is x power 2. Then taking q, it will be q x to the power of 2 minus 6qx plus 9q. Perfect. Collect the like terms together. We have px to the power of 3, x squared with x squared, so we are going to have q minus 6px squared. Px and x will be 9p minus 6qx plus 9q. If we take this expression and equate it to the other form we've got from f of x, it will be what? Let's see how it goes. We have the first expression, 2x power 3. So we have 2x to the power of 3, 2x to the power of 3 plus, what is x power 2? Negative 7x power 2, negative 7x power 2. Also, coefficient of x, negative 12x. So we have negative 12x plus 45. Equating coefficients means what? X power 3, the same coefficients. So, oh yes, we can see that p is going to be equal to 2. Also here, we can do as another equation, q minus 6p equals 7, or another equation, 9p minus 6q is equal to negative 12, or another equation, 9q equals 45. I believe the easiest is 9q is equal to 45. So we can say that q is equal to 5. Yes? So we have p is equal to 2 and q is equal to 5 in a piece of cake. You want to make sure that your answer is correct. Put q here, like same thing. It will be 5 minus 6 times 2. 5 minus 12 will be negative 7. So our answer is correct. So what are we do in such question? Expand, equate the coefficients. You might sometimes do some kind of simultaneous equation, like taking this is equal to negative 7 and this is equal to negative 12, and solve simultaneously. But it doesn't need any kind of effort here, as it was clear from the beginning that to part C, we have sketched the graph of y equals f of 2x. Going to this equation, taking this equation once more, we can copy this one and paste it down here. Yes, then replace every x with 2x. It will be 2x minus 3 all squared. P is equal to 2. It will become 4x plus 5. Getting x-intercept and y-intercept. When we put x is equal to 0, y is going to be 3 squared times 5, which is 45. And we put y equals 0. We have a repeated root, which is x is equal to 3 over 2. And x is equal to negative 5 over 4. Do the graph directly without hassle. Yes. And x and y. As you can see, I got the y very high. And this is the x, and this is going to be 1.5. And this is going to be negative 5 over 4. And we have the y-intercept at 45. So we can draw the graph like this. Or let's say, let's repeat it so we have it in a good form. And this is going to be your graph. Going to number 9. Apparently we have the tan function. Yes, the curve with equation y equals tan x minus pi over 6, where x between 0 and 2 pi. Part of the straight line with equation y equals pi minus x. State the number of solutions of the equation. tan x minus pi over 6 equals pi minus 6. That means we need to count the number of points of intersection of this straight line with the tan function. How many points we have here? 1, then 2, then 3. So we're going to write only 3 points of intersection. So the answer is 3 solutions or 3 points of intersection. Type double I, we have 10x minus pi over 6 equals pi minus x in the interval min 0 to 100 pi. That means we are going to have like 50 repetition, 50 curves like the above curve. Okay, so we're going to have 50 curves times 3 will be 150. No, it's impossible. It is really impossible because of what? If we can look at the line will go down only. That means it will intersect with the rest of the graph that is going down in the negative side. So on the negative side, we have here only 2 points. If it continues, it will intersect with the rest of the graph. So we're going to have only 2 points of intersection down there with the rest of the graph if the graph continues, and it will continue, of course. So we're going to have 2 times 50, which is going to be 100. And we have a 1 here in the first curve will be 101 solutions. So the number of solutions for this is 101. Again, why we have 101? First of all, we have from 0 to 100 pi. That means the curve, this curve is repeated. The curve, not the line, is repeated for 50 times. But the line will intersect the curve only below the x-axis, not above the x-axis. So we have 2 points times 50 plus the 1 which is above the x-axis. This is why we have 101. The last one is tan x minus pi over 6 equals pi plus x. Okay, pi minus x, what made the curve going down? Because the gradient is negative. When it is pi plus x, pi is the point of intersection with the y-axis. Do it like this. How many points of intersection you can see here? 1, then 2. It is from 0 to 2 pi, so there is no repetition. How many solutions? Now here we have 2 solutions only, or 2 possible points of intersection. Time. The line with equation x equals a, shown in figure 3, is the asymptote to the curve with the smallest positive x coordinates. State the value of a. Type. Looking back here, the value of a. What is the value of a? It is the asymptote for the original tan graph. The original tan graph used to have the asymptote at 90, which is pi over 2. Perfect. But it is tan x minus pi over 6. That means the graph is translated positive pi over 6 in the x-axis. So we're going to have pi over 2 plus pi over 6, which will be, with a common denominator of 6, we have 3 pi plus pi, which is 4 pi over 6. That means it is 2 pi over 3. So the equation of this line, x equals 2 pi over 3. So a is 2 pi over 3 using this solution. I believe it is now obvious that we have to use the curve, the translation, in a wise way. In a wise way, which means what? We have to look at the understanding, not the normal working out we do when we transform curves. The line with equation x equals b is shown in figure 3 as well. The asymptote to the curve with the second smallest positive x coordinate. The line x meets x equals a at the point P and meets x equals b at the point Q. Find the midpoint of the line PQ. That means we need to find first the x coordinate for the point Q, as we did before. The second normal asymptote used to be at 270, which is 3 pi over 2. Again, 3 pi over 2, we are going to add pi over 6 because this is the translation in the y-axis. Take 6 as a common denominator, so we're going to have 9 pi plus pi over 6 will be 10 pi over 6, which is 5 pi over 3. So the x coordinate here is 5 pi over 3. Now we have the x coordinate of P is 2 pi over 3. The x coordinate of Q is 5 pi over 3. We need to find the y coordinate. Do we go back to the equation of curve? No. The asymptote is on the line, intersecting the asymptote with the equation of the line. So we're going to go back to the equation of the line. Y equals pi minus y equals pi minus x, which is pi minus 2 pi over 3, which will be 3 pi minus 2 pi over 3 will be only pi over 3. So the point P now, it has x 2 pi over 3 and y pi over 3. Going back to the same thing here, going to Q, we have y equals pi minus 5 pi over 3. So y is equal to negative 2 pi over 3. Again, the point Q is now 5 pi over 3 and negative 2 pi over 3. Getting the midpoint. What is the midpoint? The midpoint is how we calculate it. It is, let's call it M. It used to be x1 plus x2 over 2, y1 plus y2 over 2. Perfect. So we're going to have 2 pi plus 2 pi over 3 plus 5 pi over 3. Then divide them by 2 or multiply them by half. The same thing here. We have negative 2 pi over 3 plus pi over 3 and then divided by 2 or multiply them by half. Calculating this equation, this one will give you 7 pi over 6 and negative pi over 6. And this is the midpoint of the line joining P and Q. Going to number 10, as usual, we have to show all your working. First of all, rewrite y, because we're going to differentiate, as you can see, the point P and show the equation of tangent to the curve at the point P. So let's rewrite y first. It's 2 over 3x to the power of 3 minus 25x minus 56x to the power of negative 1 plus 194 over 3. First of all, let's differentiate. So y dash or dy over dx equals 2x power 2 minus 25 plus 56x to the power of negative 2. That's fantastic. All right. Then at the point P, so we're going to use at x equals 2. So y dash will be 2 times 2 to the power of 2 minus 25 plus 56 divided by 2 to the power of 2. This will give us a gradient of negative 3 after calculations. And this is called the gradient of tangent to the curve. Perfect. And use the point again, point P, 2 and negative 8. Using the point 2 and negative 8, get the equation of line, y minus y1. So it's y plus 8 equals negative 3, x minus 2. So y is equal to negative 3x plus 6 minus 8. So y is equal to negative 3x minus 2. And this is the equation of line, and it shows that this is why we have only 5 marks for it. The point Q also lies on the curve on C, given that the tangent to C at Q is parallel to the tangent to C at P. This is a very old question. It used to come at C1 like 10 or 12 years ago. Find, using algebra and showing you're working clearly, the exact x-coordinate of Q. Go back to the classified, you will find me making a star beside this question. Again, they are parallel, which means we are going to use the same gradient. And do what with the same gradient? Take this y dash, put it equal to -3 to find the second value of x. Let's take it here. Y dash is equal to what? Y dash is equal to -3. And y dash is 2x to the power of 2 minus 25 plus 56 over x squared. And this will be equal to -3. Great. Then multiply all of them by x squared. It will become 2x to the power of 4 minus 25x to the power of 2 plus 56 without x squared plus 3x squared equals 0. Collect the like terms. So we have 12x to the power of 4 minus 22x to the power of 2 plus 56 equals 0. Now the solution, we have to factorize, or you can also divide by 2 first. Divide by 2 first, it will be x to the power of 4 minus 11x power 2 plus 28 equals 0. Then factorize, we have x to the power of 2 times x to the power of 2 equals 0. 28, which is 4 times 7, both sum will give you 11. So x squared is equal to 4 and x squared is equal to 7. In both cases, we can say here x is equal to root 4, which is equal to 2, or x is equal to root 7, and root 7 will be the only one. Why root 7 is going to be the only one? Because basically at x equals 2, this is at the point P. So at x equals 7, this is at the point Q. You have to make it clear that x is only the only answer. Does he ask for the whole coordinate point or the x coordinate point only? Let's read it using algebra, showing all your working. Exact x coordinate of Q. So we're gonna have only the value of x. If he asked for the value of y, we would have took x equals root 7, put it in the equation of curve to find the value of y. That's it.